Okay, we're gonna, now that you know how to do derivatives, we're gonna look at actually using them a little bit. Okay. So we're gonna start off with some motion, like motion of projectiles, okay, or particle motion or projectile motion. Okay. Particle or projectile. Motion. Okay, so we have the, if we just look at a graph real quick of time and distance here. Time versus distance. Okay? Well, let's just say we have some kind of function there. Alright. Let's say time is in seconds and distance is in meters. So, what would be the units of the slope? Yeah, in meters per second. So now what is that? What is meters per second? Well, yeah, it's a velocity. All right, it's a velocity. It's also, you could think of it as the rate of change of the distance. Okay, so yeah, the velocity and the rate of change of distance are the same thing. It's also the slope of a distance time graph, because the slope is the change in y over the change in x, right? So that's meters per second. So that's a velocity. So this graph, these y values are the distance at any particular time. Okay, but the slope at any particular time would be the velocity. Okay, of whatever this thing is. So, everybody see that? You can see that from the units. It's always good to look at units of graphs to see what things mean, especially as far as slopes go. What does the slope of this mean? The slope has to be meters per second, so that must be a velocity. All right. You can always tell by the units. So always check the units there. So we have we're gonna. Another word for distance is going to be position. Okay. Now, so we have a function for position, which is the same thing as distance. All right. So the derivative of that function, which is the slope. Okay, the derivative is the slope, right? We said the slope is velocity. So the derivative of position is velocity. And it turns out that the derivative, we'll get into this later, but the derivative of velocity is, well, actually, let's look at the units of that. Let's pretend we were graphing a velocity graph. That means we're still going against time, but if we're looking at a velocity graph, that means we have a velocity over here. So if we have a velocity on the y-axis and time still on the x-axis, then what is the slope of that? Yeah, it's meters per second squared, or meters per second, okay? So if we have the slope of a velocity graph, that is now called an acceleration. That's how fast the velocity is changing. Okay? So if you look at this list here, the velocity is how fast the position is changing. The acceleration is how fast the velocity is changing. Okay? So you can think of this as f. This is f prime. I'm sorry, f prime. And this is f double prime. Okay? Now, yeah. So meters per second. So for each second, how fast are the meters per second changing? I know that gets a little confusing to think about, but you know, it's just, you know, we'll talk more about it as we have the problem. So it's like, are you speeding up or are you slowing down? Okay. So you have a velocity already. Is that velocity changing by speeding up or slowing down? That's your acceleration. Okay. Now this, for some reason, the position function, they call it s of t. I'm not sure why. Just always call it s of t. Velocity is v of t. and acceleration is a of t. So those are the way they would normally be. So you have it goes position, velocity, acceleration, and those are just the derivatives as you go down. Okay, those are the derivatives. So if you're given a position function and want to know what the velocity is at a certain time, you can do that by just doing the derivative and calculating or plugging in the time. Okay, so let's say, for example, that the position function is given by 4t cubed minus 3t plus 3. Alright? We want to know the velocity at t equals 2. Okay? So find velocity at t equals 2. Well, if you have a position, then to get the velocity, you just do the derivative of that. Okay, so v of t is going to be 12t squared, right, minus 3, and the last 3 drops out. Alright, and then we plug in that 2. So that 2 comes in over here for this t, and we get that is equal to 12 times 4 is 48 minus 3, so that would be 45. The velocity is 45. Okay, so if this function is the position function, then at t equals 2, the velocity is 45. Okay, do the derivative, plug in the time. Now, again, that's the velocity, or you could think of that as the slope of the position. Okay, you're gonna have a couple problems today, and we already did equations of tangent lines, but just to refresh your memory, if we had to write the equation of this tangent line, we need two things. We need a point and a slope. I got the slope here, 45, so that would be my slope for my point slope form. What's the other thing I need is a point. I have the t, which is really the x, right? So I still need the y. So remember, to get the y, you would plug t into the t or x into the original, right? So in this case, y would be 4 times 8 minus 3 times 2 plus 3. So that comes out to 32 minus 6 is what? 26 plus 3, so 29. So that's my y value. Okay, so I have the point 2, 29, and I have a slope of 45. So I could write the equation of the line. Y minus 29 equals 45 times t minus 2. That's the same thing you guys were doing already, okay, last week. It's just with a t in it instead. Some of the problems have t, some have x, but t is always the x axis. Okay. Any questions on that? So you're going to be dealing with some velocities, position and velocity and stuff, and you're also going to have to do some equations of tangent line. You're going to do. I'm going to give you some homework assignment here out of the book, and then you guys. Some of the book directions say to use the limit definition to find this stuff, but you guys don't need to do that anymore because you know how to do, well, you know how to do the shortcut for the derivative. So that's fine, okay? You don't have to do the long limit thing, but even though the book in this chapter says that. But since you already know the derivative, then you can just use the shortcut derivative, okay? So on page 801, we're going to do number 3 through 19. Okay, 3 through 19. Yeah, you can leave one.